Hi, so in this video I'm going to start showing you how this AMLogic S905W setup looks like. This is more or less what a product that is already built and is like a sane image package that comes from a manufacturer looks like. Can go and use it with a remote and do all kind of things, but this is not the idea. The idea is that we're going to take this thing that runs an ancient Linux version, and we're going to upgrade all of it. Do it as part of my courses, as one of the boards we work with for all kind of reverse engineering stuff and for all kind of kernel development stuff, and mostly on Linux for packaging stuff. And the board itself looks like this. This is a TF debug card that you can connect to the SD card slot, and when you do that you cannot connect the SD card itself. This is a cable that both allows us to give power, which is not the recommended way. The recommended way is actually to use the power bank, because it cannot draw enough current from USB if you plug too many things. So this is like an HDMI cable. This is why we saw the TV. And we can see your memories, and behind this fellow there is an eMMC. So let me just go and see if I can show that. And the reason for that is that it's going to be valuable, and that we're going to basically break it. Yeah, so let's see. Yeah, so this one we will not see it if we turn down the device. And we can see that this particular device also have a Wi-Fi and Bluetooth chip. It's from Realtek, and some of the devices come with some Wi-Fi chip, SSV6 something, I forgot its name, that is not on Linux mainline. So those poor people who were really good and really wanted to go into it, I gave them tasks to sort of try and port it on the driver course. It's a hard task because it's not supported for the Realtek, and there is an extra, so I'm not saying anything. So basically, just one little thing. This of course has nothing to do with anything. It's like a connection to ground, and it's like a lazy trick to do two things. One is to reset, and the other one is to create glitches to the eMMC, where to make it undiscoverable in boot time. So perhaps I will add some videos about it. The idea is that if we mess things up completely and we want to go and go from SD card, let's say, or have a U-boot that is pre-built and do all kind of things for us. If the eMMC doesn't work well, if it's not recognized, then we can skip some bugs or some issues that are due to trying to discover eMMC, or we can force some machines to not boot from it if we want to boot from some recovery SD card. Because the USB, most people will not use it, but if it can be done, I'll probably add another video about it, maybe this one on how to burn software. So a poorer person trick would be to go ahead and touch one. I don't know if I can show it here. I mean, I will not go about what each pin is, but basically here you see the light is off. Instead of disconnecting and connecting the cable, then I just did this. So this is trick number one. Okay, and we have here a Linux that is running, and for resetting it, let me get rid of the camera. Okay, so let's start to mess this up so we'll have something to work with. So first thing first, syscontrol kernel kernel syscontrol kernel.print k equals 1. You can see it's Android, you can see the devices, and now it's less noisy, which is great. Okay, great. So what we have in this device, let's see. amazing because it expects in Android by default to get something else. Let's see what happens with the device when it's unpacked. Okay, so first thing, 3.14. Yeah, it's outrageous. So AMLogic have a 4.9 version that comes like with their Android 9 version. This is not that one. By the way, we see serial because of the TF card that I mentioned. So let me just get rid of, okay, I think I already got rid of like the video. All right. So what I'm going to do is I'm going to go, if you go block ID, look how it looks like. It's dev block, it's an Android-ish thing, all right? But I'm not getting into the details too much. You should know that there are several like partitions that are that exist, okay? And they have like their respective like names. Android can name all kind of things. This is absolutely fine. Actually, the bootloader itself can also know all kind of things via a device tree blob and pass it like to Android. We're not going to deal with it. The important thing is that this is the eMMC device, and the more important thing is that usually the eMMC device will be eMMC block 1 and not eMMC block 0. You can control it, you can control the name like via device tree and stuff like that. When you run Linux, you'll see that it is usually going to be reversed, and eMMC block 0 will be the SD card essentially. So let's do fdisk on this guy, dev block eMMC block 0, fdisk-l. We don't have all the partition and segmentation fault. Fantastic. Android doesn't like it. I can go and give something else. So this is not so amazing. We're not too happy about it. So we can enumerate it like from uboot, for example, if we want. Okay. But I will not do it now. Now I'm going to just mess things up. I mean, I know what device it is because it's printed on the PCB. It has 8 gigs of eMMC, and it has these 2 partitions that let's just go and do something with them. Sorry, it's Android. We need to go maybe to data local temp, but I'll just do something else. It's a RAM disk, mount dash oh, I'll remount it. Remount RW / Megdir foobar. Wow, amazing. Started this for stamp if you speak the language. Yeah, and let's do this. dd if equals dev. I will not connect an SD card. I can connect like a USB. I can open like a telnet, I think, here if it's like compiled within this BusyBox. This is so ancient. Let's see how ancient it is. BusyBox. Sorry, what about this? They put here BusyBox, how kind of them. There's also like a ToyBox Pro 120. Yeah, 126. Whew. Yeah. It's built then because I built it in some version. I took something that I built like from the OSP code of some manufacturers some years ago. That's fun. Alrighty. So what we have here, I could also get like this firm package from other things, but I just had this, so I used it. It doesn't belong to anyone from the manufacturer. I think it's good, not violating anything. It's all good. Okay, so I know how big this device is. Okay, I just don't want to go to boot right now. And what we also have here are a couple of partitions that are 4 megabytes in size, and they are not so common. Okay, they're called boot 0, boot 1. I'm going to do the following. I know how big they are. They're 4 megs, but I'm just going to prove it. I'm going to do dd if equals this fellow, of equals let's do boot 0 image, bs equals 1m, just for fun. Never mind. So it's not 0, it's eMMC block 0 boot 0. And we have here 4 megabytes. Okay, let's just prove that. But that's 4 megabytes. All right, that's like a bash arithmetics or shell arithmetics. Okay, good. We'll do the same for the other one. Okay. And let's look at the files. They're identical. And let's just for fun do xdump -c. Let's see if we have less here. No. xdump -c to either of them. Alright. And let's go to let's pipe into head /100. So you see this, we see that this at AML, and if we do more of them, we will see them also in other places, I think, if I remember correctly. Yeah, but I don't really feel like looking for them. Okay, we can go and do them like the strings. If they have strings, they have strings. Great. Yeah, everything is a string. This was a mistake. Let's just do like this because I don't want to make a 5-hour video. And we have like this 8 at AML. Okay. So we have this. This is good. This is nice. Now let's see how many. What we have here, like on the root. How many it is temp fs? I know that. Yeah, so we had this, and we already know what they are. We already know that they're identical. I'm going to delete one of them. Okay. And what I'm going to do is I'm going to do the dev block MC block 0. Okay, I know it's 8 gigs or 16 gigs or whatever, so I'm going to do block size equals same let's do count equals 4. Okay, this will be our OF. Alright, so I'm going to do MD5 sum to the thing here, and here it's different, alright? However, if I look at it, I want a -c. Then again, I'll see like this AML. And here indeed I do see AML like in several other places. Okay, so we have a header and it starts like very early in the eMMC. Okay, so we have this header, alright, and we want to go ahead and see what it is that we actually want to do with it. Okay, so we have it like in several places. In another video I will talk about like the structure itself, especially when we want to actually fix something. But before, let's do something brutal and get rid of some things here. Okay, so let's say I'm in Linux and I'm making like a terrible mistake, and we'll do this. I'll do DDIF equals dev 0, OF equals dev, no, dev 0 will exist, I believe. Let's double check it. Count equals 1. Yeah, it exists. Great. OF equals dev block MC block 0. Okay. And I'll go ahead and do something terrible with it. Wow, how terrible. I'll do BS equals 1M. Count equals will not do, let's do 2 megabytes, okay? That's what I'm going to do. So size will be count equals 2. So I did something like really bad here now, okay? And I'm going to reboot. It's Android, we need to give it a reboot command. So things still happen, the kernel still boots, everybody's still happy. Why is that? Because there are boot blocks in this eMMC block 0, boot 0 that we had here. So I'm going to do something else. First of all, syscontrol kernel print k equals 1. I could also go to sys to proxies and the other kernel print k. I'm not going to do that. So I'm going to do something else. I'm going to do echo ddif equals dev 0 of equals dev block mc block 0 boot 0 bs equals this count equals, let's do 2, okay? And I'm going to also do it for the other one. I'll corrupt it in another way to count equals 3, okay? I don't remember exactly the numbers. I'm doing it like live, okay? So I'm doing reboot, nothing. Why am I emphasizing nothing? Because if we wipe things properly and not halfway, and here we just took, I already know that we need like 4 to wipe like a 4 megabytes, okay, for all kind of reasons. But if we do it properly, as I will show either on, maybe I'll pause this video or another video, then we get, you will get something like from the boot ROM where it's going to say, hey, I'm trying to read, like from bootloader, from eMMC, from all kind of things like that, okay? So that's what will happen there. So this is like a first sign of corruption, and there is really nothing I can do if I get to this device. However, lucky enough for us, there is still hope, okay? Why there is still hope? Because if I reset it, and now I'm being lazy and like using like this resetting trick, you see what we have here? The USB is being identified. If I connect it like to the right port, there are 2 ports over there. So product GX chip, manufacturer AMLogic. So if I have this available, I can go ahead and either use the AMLogic like a flash tool from Windows, or here I downloaded it like from Kadas. All right. So what I do is I have like this file that I add like in that I'm flashing, okay, and I'm just going to run like the flash tool. There are several tools, both for like flashing and like for connecting in the first place. And in the same way, look what I see, like we flash. It doesn't matter what we did exactly, what we did there. And this is where we got stuck. And later, like we see that it loads like the ARM trusted firmware, like the BL2 build, the DR test, blah, 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 blah. Now important, in some of my courses, I actually give an overclock version, which creates all kind of memory glitches. And then it exposes very, very, very hard to find or debug Linux bugs or Linux kernel bugs, because it tries, but it works with the wrong like initialization. So this has like the right one, like for the manufacturers. So it boots this U-boot and it passes itself like the flash tool, we can do it also like with other tools. It passes itself to burning mode, and then it receives all kind of messages and repartitions things. And here we can see that like it downloads, and we see it because I have a serial device. But even if not, I can go and blindly see that like the flash tool does not fail. Okay, so these particular utils, I got them from, let's see, like tons of smart people did tons of like open source work. Very noticeable one is Neil Armstrong. Yes, that's his name. And if somebody who knows him hears that, then tell him that I said that he's a really smart guy and like extremely contributing guy. So yeah, and a cool name, you know, space and stuff. So yeah, so touche Neil. So anyways, yeah, like this tool, the same tool comes from here, and like Neil made like all kind of like Python scripts called PyAMLboot that I might use as well. All right, but look, I mean, it wrote enough things I could just like break it and reset it, and it will be good enough. You know what? Let's just do that. It's downloading. It's in the middle, and I'll try to be quick enough. I reset the device. That's what I did, and it prints a lot of things. It's actually nice. It's all good. Yeah. So it didn't finish like with all the partitions and didn't finish doing everything, but it does have a prompt, so it's actually pretty good. Or maybe it did finish. Yeah, it didn't, but it doesn't matter. Okay? Awesome. So we got to that. So we have a way to recover. So in this part, which will be like the first part, although maybe I did something, we covered the following things. We looked at how to. Hi, sorry, I didn't like it to put it here. So we did several things. We looked at how, like, what is connected like to the device. We looked at how to hackily reset it without like connecting, disconnecting. We understood the peripherals that are connected to the device. And other things that we did, which is like the device, okay? And other things that we did were actually messing up the device in a way that nothing is recognizable, which is terrible. And the last thing was recovering it, okay? If there is like a firmware update package. So that's pretty cool. Like the official instructions say to do it like from Windows, but there are tools from Linux as well. So that's what's been used. And this is of course not a part of the device. This I took from some multimeter that broke, and it just helps me to touch like effectively and to do some tricks. I don't know if I'll show like glitching eMMC because there needs to be some timing, and at the moment I don't remember exactly what pins it is on. I'm doing quick videos, I'm not editing it, but this could be useful. So we have a way to recover. If we have a way to recover, we can go and break the device and play with it and do some things, which we do. It's useful. We do it in some of our courses, and actually this kind of device is allowed to do some of like the low-cost courses that don't use like a very particular vendor, just use something that are off the market. So I'm not like advertising anyone, and yeah. So because people always say, oh, your stuff are wonderful, but unless they want to do some things that I'm idealistically against, let's put it this way, people will not want to afford or cannot afford like what I would usually charge. I suppose I'm still part of the Linux Foundation roster, but I always say, look at their prices. I've been teaching there since 2015, and I think I've done pretty decent work. So, yeah. All right. And it's around the same ballpark, but some depends orders. Okay. So this is like the first part. No, I never like advertise everything, but everybody does it, like in this meetup group that I'm running. So yeah, feel free to reach out. I mean, I still do courses, but I'm very selective in what I do. All right, so that's the first part, and we'll continue to the next part. In the next part, we'll start directly from destroying the device, this time in a little different way.